Okay, math theme for meet number 1, category number 2 is inequalities and absolute value. The 3-point question could be either a linear inequality problem or it could be an absolute value problem. So I've selected one of each for us to practice from 2016, 2017, I believe. Here is inequalities. They have us, it's a compound inequality. There's different styles they give you, but let's just try this one. Solving this, I'm going to add 8 to both sides to get 15. 3x, let me write that down. 3x is less than or equal to 15. And then divide both sides by 3 to get x is less than or equal to 5. And then to solve this one, I'm going to subtract 8 to get negative 4x is less than or equal to, when I subtract 8, I get 12. Divide by negative 4, and since I'm dividing by negative 4, I need to remember to switch the symbol around. Divide by negative 4, and I get negative 3. Not showing much work because I'm having trouble. I'm not that good at writing with the mouse. And then it's the word and in between. So for compound inequalities, let's see if this is a trick where it ends up being no solution or if there is a solution in between the two numbers. 5 is larger on the is a bigger number or greater than negative 3. We want values that are less than 5, so going this way, and at the same time greater than negative 3. So this is not a trick. This is a pretty straightforward question. So I can write my inequality like this and show that x is between those two numbers. There are some trickier ones sometimes that they give for 3-point questions, but there's a basic kind. Maybe the 3-point question this year will be an absolute value problem. Here's an absolute value problem. Trickier than the previous thing we did, I think. When we have absolute value, we want to get the absolute value by itself, and then we'd like to look at the different values that it could equal. This is a less than problem, so I actually am going to try to find the critical points. I'm going to start off with that 3x plus 5 to find one of the critical, minus 5, to find one of the critical points. I'm going to have it equal, as it's written, 15 plus 7x. And if you recall, when you're dealing with absolute values, you also want to consider the scenario that the 3x minus 5 could equal the opposite, could equal the negative. So I'm going to write that as 3x minus 5 could equal the opposite of this, which would be negative 15 and minus 7x. So I'm going to solve these two to get the two critical points. All right, let's see if I can skip some steps here. I'm going to subtract 3x from both sides to get 4x on this side. I'm going to subtract the 15 to bring the 15 over here, so I'm going to have negative 20. And then I divide both sides by 4 to get negative 5 is one of my critical points. Okay, over here, I'm going to add the 7x to bring it over here to make it 10x. I like keeping things positive, if I can. And at the same time, I'm going to add 5 to both sides, and that's going to give me negative 10 over here. And then when I divide by 10, I'm going to find out the other critical point is negative 1. All right, so the critical points are negative 5 and negative 1. So I'm going to test points out in here in between each. Well, not in between each, but in each of the zones, if you will. So I'm going to plug in a number that's less than negative 5, so negative 6. If I plug in negative 6 times 3 is negative 18. Negative 18 minus 25 is negative 23, but the absolute value of negative 23 is 23. And we're going to see if that's less than. If I plug in the negative 6 here, negative 6 times 7 is negative 42. Negative 42 plus 15 is like negative 27, and this is not true, right? Okay, now I'm going to test a point, so it's not true over here. Now I'm going to test a point in between negative 5 and negative 1. How about negative 3? Plug in a negative 3 here. Negative 3 times 3 is negative 9. Negative 9 minus 15 is negative 14. Then the absolute value of negative 14 is positive 14. we're going to see if that's less than when I plug a negative 3 in here. When you plug a negative 3 in here, negative 3 times that is negative 21. Negative 21 plus 15 is negative 6. That's also not true. So I'm hoping when I plug in a number larger than negative 1, it works out. And I'm going to plug in my favorite number to test, which is 0, because 0 is larger than negative 1. When I plug in a 0, I get negative 5. The absolute value of negative 5 is positive 5. And when I plug in a 0 here, that wipes that out. I get 15. And yes, 15 is less than negative 5. So the only place there where it works, where this side is less than this side, is when we were greater than negative 1. So that's my answer. X is greater than negative 1. Now you may want to, sometimes you want to check a problem to see if it has the equal sign. We don't have equals, so it's just going to be greater than negative 1 is my final answer to that one. That one was that was a lot more work to get 3 points than the previous one. So different years, they have different levels of difficulty, even on the 3-pointers. For the 4-pointers and 5-pointers, probably need to have some Algebra 2 background. Like for this problem here, find all the values which satisfy the following. They already factored it. Sometimes they don't do that. It's less than 0. I can see that there's a double root at positive 2. And there's a single root at 5 and a single root at negative 2. So if I were graphing this, I know it goes through, well, let's see, it's a 1, 2, 3, 4. So that means it's going to start up here. It's going to go through negative 2. It's going to come up, and it's a double root at positive 2, so it bounces. And then it comes back through 5. Again, this is just with my Algebra 2 knowledge. This was at 2. This was at negative 2. I should have labeled those earlier. So where is it less than 0? In this domain and in this domain, and not at 2 because there's a 0 there. Anyways, that's just a quick for a more difficult one. And another more difficult one would be to solve this. This is why I think you probably need some algebra 2 in your background. To solve this, it's a cubic function, and we would have to relate this to 0. I'm adding 3x to both sides, and I'm going to subtract 3 from both sides. So you have this cubic function. You're going to relate it to 0 and tackle it like I did before the previous problem, except this isn't factored. So you need to factor it. I do notice this has a 1 and a 3 as the coefficients, and this has a negative 1 and negative 3, so I could probably factor by grouping, or maybe you could use the rational root theorem and stuff like that. Not to scare the younger kids, but keep in mind the easier problems, the 3-point questions would be like this matrices or like an inequality problem. That's it. Hope you have a good meet.